Okay, good afternoon. This is the third and last video for week 6. We're talking about sine and cosine ratios. Last video we talked about tangent, and if you came live on the Zoom, I read you a story about Princess Sokotoa, and remember it was her right toe that was very, very large. Well, these ratios only work in right triangles. Okay, one of these ratios is called the sine ratio. And this ratio is the length of the opposite side to the acute angle. Well, remember the princess's name is Sokotoa, and tangent was opposite over adjacent. And see, you have the T in Sokotoa, followed by O for opposite, A adjacent. So tangent is opposite over adjacent. This middle letter goes on top. So when we talk about sine, sine is opposite over hypotenuse. So here's my triangle. We're always going to label the three sides. Well, adjacent and opposite is already labeled, and that's using the reference angle of 60. And then this is my hypotenuse because it's the longest side and it's across from the 90-degree angle. So if we want to find sine of 60, we're going to take opposite over hypotenuse. So from 60, the opposite is radical 3 and the hypotenuse is 2. That's how easy it is. It's the sine ratio. The sine ratio is opposite and the hypotenuse. Okay. Now let's look at the next ratio. This is called the cosine ratio, and this is adjacent over hypotenuse, comparing the length of the adjacent angle to the side adjacent to the angle to the length of the hypotenuse. So if I'm using the same triangle, now if I'm going to do cosine of 60, cosine is adjacent over hypotenuse, and from 60 the adjacent is the 1 and the hypotenuse is 2, so that'd be 1/2. I want you to pay attention to the princess name Sokotoa. Sine is opposite over hypotenuse, OH. Cosine adjacent over hypotenuse, and tangent opposite over adjacent. Those are going to be very, very helpful. Okay, let's look at this next set. And when you do problems like this, it is super helpful to write Sokotoa down on your paper, because then it's easy reference. I wrote it down here so you can see it on the video. Okay, let's look at how would I use this sine, cosine, or tangent in order to find the missing letter A when I have 23 degrees. Well, one of the first things we're always going to do is we're going to label the different parts. This is my reference angle, okay? So that's my reference angle is where I'm standing. So if you want to draw my little arms right there, okay? Across from the 90 degrees is the hypotenuse, and then this is the adjacent, so that means this is opposite. So once I label everything, I'm going to circle the information that I have. So notice I have hypotenuse, I have that at 15. Adjacent, there's no information listed here, so I'm not going to circle that. And even though I don't know what the opposite is, there's a marker there, a variable there, so I can actually calculate what it is. So I have opposite and hypotenuse. As soon as I have hypotenuse, I know that it's not tangent, because see how tangent has an O and an A in it? These are the only two that have the hypotenuse. So I've narrowed it down to either sine or cosine when I have information with the hypotenuse. And so this is the opposite. Sine has opposite in it. So I know I'm going to use sine here. So I'm going to go sine. And what is my angle of reference? The angle of reference always follows the trig ratio. It's always after sine, cosine, or tangent. So I have sine. And then my opposite is A, and my hypotenuse is 15. So once I set up my proportion, I can solve it. I take this trig ratio, the sine, and put it over 1 so I can set up cross products. And we're going to get A equals 15 times sine of 23. So I know I can solve for A by just going sine of 15 times sine of 23. So here's what I have to do. I have to go to my calculator. So we're going to go to Desmos. And you see how Desmos Scientific Calculator pops up? Okay, I'm going to go straight to the calculator. And we're going to type in 15 times sine, I fixed my screen so I can fit this in, of 23 equals, oh look at 5.86. There it is right there. So all I have to do is go back to my paper and write A equals 5.86. Okay. And we're going to, that's it, we solved for A. Let's move to this next problem. Again, what is it that we have? We have our reference angle of 37. It happens to be in the same location. Here's my arms. So my arm is touching these two sides. One of them is adjacent and one of them is hypotenuse. So this is across from the 90. So this is my hypotenuse. So this is my adjacent and this is my opposite. Let me circle the information that I have. I have hypotenuse, nothing in opposite, and I have adjacent. So I have to figure out which trig ratio am I going to use. Adjacent and hypotenuse. Notice cosine, the C has A and H. A and H. So that's the information I have. So we're going to set up the ratio by using cosine. And right after you write the trig ratio, whether it's sine, cosine, or tangent, you put the degree. And our reference angle is 37, so I'm going to use 37. Equals adjacent, the middle term always goes on top, over hypotenuse, A, 8. And so here we go, set up our cross products, and we're going to get B equals 8 times cosine 37. And so I'm going to know what B equals as soon as I go to my calculator. So we're going to come back to the calculator, and we're going to change this to 8 cosine 37, and we get 6.389. 6.389. Well, I can round that to 6, well, I can put it 6.389. If I rounded it, it would be 6.39. Okay. I could give you this or. All right. Oops, let me see. You can't see what I'm writing. Let's go back. 6.389 if I rounded it at 6.39. So I'm going to review, and we're going to do sine is SOHCAHTOA, opposite over hypotenuse, which when I look at this little triangle here, this is my reference angle, theta, sine of theta is equal to opposite, which is delta y, so delta y over hypotenuse. Okay, cosine is adjacent over hypotenuse, and this is adjacent is represented by delta x. That little triangle is delta. It's a Greek word that means change over hypotenuse. And then tangent is opposite over adjacent, which is delta y over delta x. Okay, the change in y over the change in x. And notice tangent, okay, the change in y is my rise, the change in x is my run. Okay, let's look at the last page here. Nope, here we go. So for all of these, we are just going to try to solve them. I'm going to do a couple and leave the rest for homework. So decide whether we're going to use opposite or adjacent. Everything is determined by your reference angle. So if we look at this first problem right here, this is 17, my reference angle. So here's my little arms right there. Let's label hypotenuse. Always label the hypotenuse I label it first because it's across from the 90. My arm is touching this side, so this is adjacent, which means this is opposite. So what information do I have? I have hypotenuse and I have adjacent. Okay, I'm going to write SOHCAHTOA here. So I have it as a reference. And I have adjacent and hypotenuse. Oh, let's see. AH. It's going to be cosine. So I'm going to go here. I'm going to do cosine of my reference angle of 17 equals adjacent, which is 3, over opposite, which is x. And here we go. We're going to set up our proportion and do cross products. In this problem, we have 3 equals x times cosine of 17. Well, our goal is to solve for x and get x by itself. So in this problem, we have to divide both sides by cosine of 17. And we're going to get x equals whatever I get when I plug that into the calculator. So let's go back to our calculator. And we're going to get 3. I'm going to hit divided by. Now I could put cosine 17 at the bottom. Oh, we get 3.137. 3.137. So go back to my paper. 3.137. 3.137. And what does that mean, 3.137? It means that this length right here is 3.137. And it makes sense that this number is larger than 3 because this is the hypotenuse and it's the longest side. I'm going to do part D. The last one I'm going to do as an example. And here, my reference angle is this one. And, oh, kind of wrote all over the place. So I'm going to label my hypotenuse. This right here is my hypotenuse. Hypotenuse. Okay, from this side, if those are my arms, 1, 2, this means adjacent because my arm is touching. And then across is going to be opposite. So what information do we have? We have opposite and we have adjacent. There's nothing about the hypotenuse. So immediately, as soon as there's nothing about the hypotenuse, see how these two require the hypotenuse? Tangent does not have the h in it. So that's a clue, a big clue that you're going to use tangent. So we're going to do tangent of 62 equals opposite over adjacent. I'm going to set this up again, doing 2 proportions where you have to do division here because this I get x times tangent of 62 to divide by tangent of 62 we'll leave x by itself. So we're going to divide by tangent of 62 here, divide by tangent of 62 here, and you're going to get x equals, and you're going to type this into the calculator and get an answer. For the rest of this page, there's our 1, 2, 3, 4, 5 problems to do, and then you're going to finish this one on your own by typing 5 divided by tangent 62 into the calculator. All right? We will be practicing live again in class. Please join us. Have a great day.